Hello, my name is Michael Delgado, and I will be performing uh, experiment number 3, colligative property lab. So in this lab, we're gonna have three different things that we're gonna be performing. The first one is freezing point of water. After that, freezing point depression, and finally, we're gonna be doing the osmotic pressure. So let's begin. So for this lab, the first part, we're gonna need three beakers. We have it here. We have it labeled. And now we will be uh, placing the beaker on the balance, and we wanna add 70 grams of 70 grams of ice. Okay, we have ice here. 70 grams of ice and 30 grams of water. Okay, so we want to be recording the mass. That should be 100 grams. Now, we're going to be removing the beaker from the balance, and we will be inserting a thermometer, Celsius, okay, in here. I'm going to be stirring it. So we want to be recording the freezing point. So the freezing point is the point, the lower point that the thermometer will be measuring. So it stopped. So we want to be measuring this point that is 0.1 degrees Celsius. So now we're going to be doing the second part, the freezing point depression. So in this part, we're going to be weighing approximately 20 grams of sodium chloride. So 20 grams sodium chloride. So we want to add these 20 grams to the icy water that we have here. We want to place carefully the thermometer. And we know how the temperature is going down. Minus 2.5 degrees Celsius. So so now we are going to repeat the process, but this time with calcium chloride. So we need a beaker 2. We add we add 70 grams of ice. Okay. And 30 grams of water. So we will be recording again the mass of ice plus water, 101 grams. So now we want to be stirring the ice and water mixture in the beaker. We want to be weighing 20 grams of calcium. Okay, 20 grams of calcium. So we have here like 71 grams. So we need to so we are we want to add, we have like 20 grams of calcium chloride. There we go. 20 grams, and we're gonna add to the beaker number 2. So we're gonna be inserting the thermometer. I'm gonna be steering. This time solution is going up. Solution temperature is going up. .7 degrees Celsius. So the temperature for calcium chloride reached 7.7 degrees Celsius. The lowest, to say. So now we're gonna be repeating this process, but with glucose. We already have the lower temperature for calcium chloride. Actually, it's a little upper than the one that we have for sodium chloride. So now we are going to be performing the same process, but with the glucose. For that, so we have to start by weighing uh, 70 grams of ice again. More. There. I'm going to be adding 30 grams of water. We will be recording this measurement. Okay, a little more. So we have here like glucose. We have mass of water and ice. So now we're going to be measuring 20 grams of glucose. I think I would be needing more glucose. I need more glucose, so I'll be right back. What? So we already have here the mixture with glucose, and we already have measured the temperature, and the lowest point was recorded. Well, now we are going to be doing the osmotic pressure part. So in this one, we have here approximately 8 inches of dialysis tubing. So we are waiting for 5 to 10 minutes. This tubing will be soaked. So in the meantime, we're gonna be obtaining two beakers. We have beaker 1 and beaker 2, and we will be measuring 1 gram of starch. So let's begin. This one, we add in a gram. Oh. So we already have 1 gram here, 1 gram of starch, and now, according to the instructions, we have to obtain a graduated cylinder and measure 99 milligrams of water. 99. So we have to find the one of 100. So I'll be right back. So we already have the 100 milligram cylinder. So we're gonna be adding 90. So 99 millimeters, or 99 millimeters. I mean, milliliters. Milliliters. There. 99 milliliters of water, milliliters. Solution 1, and stir the solution. So we're gonna be adding this here. We're gonna be stirring it. This one is a 1% starch solution. So now we will measure 3 grams of starch into a beaker labeled solution 2. So this one over here. So close this 0. Okay, we're gonna put 0 in. So now we are preparing solution number 2 with 3 grams of starch. Yeah, okay. We have 3 grams here. And we want to put 97 milliliters of water. 97. Take a little bit out. A little bit more. Okay. So we're going to be adding this, and we are doing now a 3% starch solution. So what we are doing now is transferring 30 milliliters of 1% starch solution. So we are measuring here 30 milliliters. Oops. 30 milliliters. Put it here. Okay. And we will be adding 60 milliliters of water to this solution. So we are diluting this solution. So we have 50 here. So we need 10 more. So we have 50 milliliters of water. And we will be adding this to the dialysis tubing. So we already have this here, the dialysis tubing. We have it in one of the sides. We twist it, and after we twist it, we use a piece of dental floss to seal it, one side of the tubing. So now we have to measure 25 milliliters of this solution. 25 milliliters. So okay, we're gonna be using this in order to fill this dialysis tubing. So Okay, so we will repeat the process. We're gonna be twisting it, and use a dental floss to seal it. So we already have it closed in both sides. So the next step is to okay, squeeze the tubing gently. I already did that. Measure the mass. Okay, we want to be measuring the mass for this. So mass of the dialysis tubing with 1 starch solution, 10 grams. 10 grams. Okay. Place the dialysis tubing into a beaker, label number 2. So we have to add this inside the other solution. Okay, the other solution, and observation that made in this lab. So we have to put this here. So in this case, we have to wait 3 days. So next Sunday, we'll be seeing the results, the change in the mass in both solutions. So see you then. See you then. So today we have the third day after we put the dialysis tubing inside. So a 3% starch solution. So today we're gonna be measuring the final result of this experiment. So we're gonna take the solution, the dialysis tubing, and we will be recording the weight. Okay. So after 3 days, starch solution, weight. Okay, so that's all for this experiment number 3.